Let's solve e to the 2x minus e to the x equals 56. Notice we have an equation that's in quadratic form, which is ax squared plus bx plus c equals 0. To see the quadratic form more clearly, please recall that e to the 2x is the same as e to the x squared. If you can raise an exponent to an exponent, this means you're multiplying exponents. We're seeing the rule in reverse. So let me rewrite my equation so it looks a little bit more like it's in quadratic form. So I would have e to the 2x, which is e to the x squared, minus e to the x. And then if I subtract a 56 from both sides of the equation, minus 56 equals 0. Now my form is a little bit more like my ax squared plus bx plus c equals 0 form. But the variable still looks a little strange, but I can take care of that with a substitution. I'm going to go ahead and place a w here and a w here. So I'm going to let w equal e to the x. So this then gives me w squared minus w minus 56 equals 0. And I'm just going to factor it. Numbers to multiply to negative 56 and add to negative 1. This would be w minus 8 times w plus 7 equals 0. Setting each factor equaling to 0, w minus 8 equals 0, or w plus 7 equal to 0, I can solve for w and I find I have two answers. W equals 8, or w is equal to negative 7. But recall what w is. W is actually equal to e to the x. So I can write e to the x is equal to 8, or e to the x is equal to negative 7. But e to the x is always positive. So I don't have a solution from this factor right here. I only have one solution. Taking the natural log of both sides of the equation, I have x is equal to the natural log of 8. That's my solution.